All right, let's look at this question 9, also from section 4.1. So we're given a graph here of the velocity of an object. Object's moving in a straight line only along the horizontal axis. So we're assuming that curves make up parts of the graph are either portions of straight lines or portions of circles. Okay. All right, so part A, determine the exact total distance the object traveled on the interval 0 to 2. So I am looking at the area under the graph here, and I should probably split this up into two distinct areas. So if I want to find the change in position over the first second, I think I'm going to find the area there. That'll be the area under a triangle. So 1/2 times the base, which is 1 second. So let's label these axes in terms of their units. So this will be time in seconds. And the velocity of time is given in feet per second. So the base length is 1 second. What is the height? The height is 1 foot per second. So that comes out to be 1/2 a foot. So then I need to find the area of this next portion here. And that'll give me the change in position over the second. So from t equals 1 to t equals 2. So what does this give me? How do I find the area of a circle? That's pi r squared. So what I have here is 1/4 of a circle. So 1/4 pi times the radius squared. What is the radius of this circle? Well, you can either look vertically or horizontally. Either way, the radius is going to be 1. It's hard to give a unit to when you're talking about the radius, but for now, let's think about it numerically. So because I can measure the radius either vertically or horizontally or anything else, actually, let's just keep it numerical. Try not to muddy the waters too much. This comes out to be pi over 4. Or pi over 4 feet. Let's approximate that a little bit. So 0.785. So what's the total distance I traveled from S of 0 to S of 2? Oh, sorry, from t equals 0 to t equals 2. So if I add these things together, so that'll give me S of 2 minus S of 1 plus S of 1 minus S of 0. These middle terms cancel. So S of 2 minus S of 0 is equal to, actually, let's not do that yet. What's S of 2 minus S of 1? That's 0.785 feet. And what's S of 1 minus S of 0? That is plus 0.5 feet. So I get approximately 1.285 feet. One thing I point out is that in this situation, the first 2 seconds, the object is traveling in the same direction the entire time because the velocity is positive the entire time. Right, moving on to part B. What is the value and meaning of S of 5 minus S of 2? Or y? Okay. So first, let's find the value of it. So if I want to find the change in position from S of 2, or from t equals 2 to t equals 5, I am going to find the area associated with this graph across that interval from 2 to 5. You can either look at this as a trapezoid or as 2 triangles and a square. Let's look at it as a trapezoid so I can find the area of this thing all at once. So how do I find the area of a trapezoid? That's equal to 1/2 times the height times base 1 plus base 2. So basically, if this formula does not look terribly familiar to you, that's okay, but I'll just briefly explain where it comes from. Basically, what we're doing with the trapezoid is we're basically envision what happens if we alter it so it becomes a rectangle. So What's the height of this rectangle? It's the same as the height of the trapezoid. But what's the base of this rectangle? The way I found that was by averaging the length of the longer base and the shorter base. How do you average two things? You add them together and you divide that by 2. So this is where that formula comes from. So let's go ahead and find the area of this trapezoid. 1/2 times the height. What's the height of this trapezoid? It is -1 feet per second. Why is it negative? Because this trapezoid extends below the x-axis. And it's probably strange to you to think of area as possibly being a negative value, but in this case, it is possible. And then what is the base 1? Let's call base 1 the smaller of the two bases. That'll be 1 second. And then what is the larger base? That goes from 2 to 5. That's 3 seconds. So what do I get here? I get 1/2 times -1 feet per second times 4 seconds. All told, I get -2 feet. So there's a value. What's special about that value? So over these next 3 seconds, that means that this object went, I guess we can say backwards, whatever our negative direction is in this case. So typically we think of, since it's moving along the horizontal axis, we think of positive movement being right and negative movement being left. So in that language, I'd say that in part A, our object moved 1.285 feet to the right. And then in part 2, the object moved 2 feet to the left. All right, finally, part C. On which time interval did the object travel the greatest distance? 0.2, 2.4, or 5.7? So, what's the distance the object traveled over these 2 seconds? I think that's 1.285 feet. We've already calculated this. What about 2.4? So what did we find? We found -2 feet. But what's the distance that it traveled? So remember, distance is always non-negative. So we might have moved 2 feet in the reverse or the backwards direction, but all we really care about for distance is that we moved 2 feet. So 5.7, but we have not calculated yet. On which interval did the object travel the greatest distance? So now let's find the distance associated with 5.7. So find the change of position from 5 seconds to 7 seconds. We're going to find this area. So how do I find the area of a circle? The area of a circle is pi r squared. I have a half circle here, so 1/2 pi r squared. What is our radius? So I think the center of this circle will be at 6 seconds. That radius will be 1. And again, I'm just going to treat it as numerical because talking about horizontal and vertical dimensions of a circle might be a little muddy. So I get 1/2 pi or 1.57. So, and by the way, that feet, is it negative or is it positive because it's distance, or is it positive because it's moving in the positive direction? The answer to both those questions is yes. So over which interval did I travel the greatest distance? It looks like that was the middle interval from 2 to 4. So when the object was actually moving back.